And here we go. All right, welcome to 5 Live Free Code School. Okay, we got a couple of people that'll arrive probably a little bit later, but we're gonna go get moving. Oh, good, here's Sudesh from over in England. Let's wait for his audio to come up. Hey, Sudesh, how are you?
Hi, Rick. How are you?
Doing well.
I'm good, thank you.
Okay, good. So before class started, I was talking with Alexandra and Dana about the SQL lab. Were you able to work all the way through that?
I did create the 4 tables.
Okay. Did you get to the point where you defined the relationships between them and that sort of thing by?
No, that's where I stopped. Yeah.
Okay, good. All right, make sure you get through that. I was just talking with, like I said, with Dana and Alexandra. It'll probably take you about 3 to 4 hours from that point forward to finish.
Okay. Yeah.
Tops. Okay. And like I was stressing in those instructions, go ahead and read everything about it. And by the way, I'm going to actually show people the link in case they view this in the future and want to know what we set out. You can see this URL right here. And in the future, it'll be in that Dropbox, but I just want people to see what we're talking about. And there's 3 different sections to this. All right, good. You know, I don't know if it recorded that because I didn't share my screen. We'll do that again. It's probably just showing the Zoom thing. All right, this is the SQL assignment that we set out on this towardsdatascience.com site, and it's 3 parts. Okay, good. All right, so here's what we're going to talk about today. And this is something I've been looking forward to quite a while. We've only got one more big thing to fill in before we can actually call ourselves full stack developers and start building some complex projects together. We're going to flesh out the last part of this SQL database thing. Now, there's a lot more you can learn about SQL and about databases and everything, but I think we've covered enough that you'll be able to work through this next subject and building our full stack project. And here's what the subject is. It's connecting from some computer program that you're writing over into a database and running SQL queries, whether they're to read data, update data, delete data, right? Create, read, update, delete. You want to find a way to do that. And it's a pretty interesting subject, and it's one that almost every application has to solve in one way or another. So here's what I want to do is I want to show you this with an already existing project. And then what we're going to do is together, we're going to start making it so that rather odd console app that we built, a couple months ago, instead of using a single text document as the database, which is totally janky, we will actually create a database for it and start storing that information in the database. And we'll make it so our application can read and write to and from that database. But first of all, I'm going to show you an existing installation. So let me get this thing set up. I am going to pull up my SQL workbench. And then I'm going to share my screen. All right, now, let me share my screen here and show you. I'm going to reinforce something we've talked about several times before, but it's going to become pivotal to understanding what we're going to do in connecting our computer programs that we write to a database. Now, notice that here where it shows these different connections, I've got 2 different connections. One is a database server that's out on the cloud in my Microsoft Azure account, but the server that I'm going to connect to is local. And again, I want to reinforce this program, my SQL Workbench, is a computer program that's totally separate from my databases. My databases are not in this program by any stretch of the imagination. All this program does, and it sounds really simplified, but all it does is allow you through a user interface, connect to a running database server and all the databases that might be on it, and then to send commands to that database server, SQL commands, and to view the results. That's all this thing does. But what we view when we use this program is we're not looking at a computer program that contains our databases. We're looking at a program that lets us connect to a database server, which contains our databases. Any questions about that clarification? Okay. So the reason I bring that up is when we look at a computer program that I wrote, it will connect to a database server in exactly the same way this MySQL Workbench program is, but I'll be able to show you the code that's making the connection happen. And then later, as we adapt that console application we made a while ago, that operate from the terminal, you'll also see, because we're going to write it, the code that connects to a database server. But for now, I'm just going to open it up and connect to the database server. All right, so there is a database in here called CSRDB. And I want to show you a little bit of the structure of it. In fact, I'm going to close all of these tabs. I don't want to save any of them. Okay. So there are 5 tables here that will be relatively intuitive for you, and then one that won't be. You can see tables where we store address information. We've already built stuff like this. We have an address ID, address line, city, state, zip. And then we have date columns in here that record when we created an individual record in this table and when we last updated that record. Pretty straightforward. Any questions about that? Okay, we've built something like this already. Same thing when you look down here at customers. This is going to be relatively familiar. We've got an ID we use. That's a primary key. First, middle, last, phone, email, might have some notes. And we have an address ID. Now, this column, what type of column is that? What do we call that column, address ID, that exists in the customer table?
It's a foreign key.
Absolutely, that's the foreign key column, and it refers to a valid primary key over in the address column, a valid entry in this column called ID. Okay, good. And we can even see that here under foreign keys, I believe. Yeah. Okay, good. All right, so that stuff should all be kind of like familiar. And let's look at the other tables here. We're going to skip over ordered products for a moment. We're just going to look at orders. If it'll expand, columns. We have a foreign key that points to a customer. We have the status of an order. There's some text associated with the order. We have when did we place the order? What's the total dollar amount on it? Any notes? And of course, when did we create the record and when did we last update the record? Any questions about these columns? And that's kind of what you'd expect from orders, right? I want to now show you the products column. And this is going to be kind of similar to what we're going to create when we use a real database for our console application that we built. Because remember, the first version of that console application we built was to work with a collection of products. Our columns here are an ID, a SKU, we had that in our lab a couple months ago, a price, a name, and we also have a quantity, how many we have on hand, we had that in our lab, a description, and of course, when did we create the record and when did we update it? Any questions about these columns, that kind of structure? All right, so that's 4 tables. Let's look at these. This ordered products table. Can anyone tell me what they think this table is for? Based on its structure, its schema.
It kind of looks similar to like the composite key we saw in the reading.
Ooh, that's genius. Yeah, that's part of it. because you're combining an order ID and a product ID.
Yeah.
It doesn't serve that function though. On this lab that you guys did over the last 5 days, wasn't there a lookup table of some sort? Here's what this is. In fact, let me see if we can get any content. Select rows. All right, so I'm going to do order by order ID. Let's run this again. Let's look here at these second 2 rows. These have the same order ID. So we've entered an order. To refresh your memory, let's look at the columns on an order. We record what customer placed the order, what its status is, some text associated with that status, when did we place the order, how much was it, and any notes. So we're referring to that twice. Order number 4 is being listed twice, but there's different product IDs in each. Now, can anyone tell me what they think we use this table for? So another question, it'll probably clarify it. Let's say you place an order. Like we've all done this a million times, probably within the last 24 hours. Each of us has ordered something online, or at least within the last week. I ordered paper plates today from Amazon, so there you go. All right, so let's look at the orders table. Is there anywhere in this table that gives any information at all about what was ordered?
No.
Not at
So
all.
this is to do with actual orders which already happened?
Yes. It's saying, if we look at this example right here, lines, the second and third lines, for order ID 4, remember orders have a primary key ID. For order number 4, there were 2 products on that order. We ordered a 37 and a 92. Now, what are 37 and 92? I don't know, let's find out. Oh. No, it's down at the bottom. No database selected. I violated my own recommendation. So on order number 4, we ordered an incredible plastic hat and a small granite computer. So now, does this table, which we'll run it again, does this make a little more sense? Order number 4 had those 2 items in it.
Is it a joint table?
No, and again, well, what do you mean by a joined table? I want to make sure you're using the word joined correctly.
It's combined order, which we did.
Like when you wrote a join.
Yeah.
Okay, good. So this is a time for a very important teaching moment. When you write a join, You're writing a SQL command that's going to be thrown up against an existing database, and it's going to return some results to you. You follow
Yeah.
so far?
Mhm.
Okay. Now, to be a little more nerdy and precise, because you are talking about joins, that SQL command you're going to throw up against an existing database, and which will return results, those commands say to get results, first look at one table that exists. Connect to another table that does exist. And if they match on a certain column, then please return the results. That all makes sense? Because
Yeah.
we've built several joins. So here's the most important part. When you get those results back, they are not a table. They're in tabular form because it's a collection of rows and columns, but they're not a real table that's stored permanently. All that happens is those results come back to whoever asked for them, and now they have a table full of data being held in memory. That's what a join is. It's a command you execute against already existing tables. So when you ask, is this order products table a join table? No, because it's an existing table. A join table is a temporary result set you get from running a query against existing tables. Does that make sense?
Yes.
Okay, good. It's a fair question, okay? Because it does accomplish some of the same kind of thing. We are connecting from the order table into the order products table and then over to the product table. In our minds, like there's a connection there. And we're even restricting what you can put in the order ID column and what you can put in the product ID column to only allow entries in it that exist over in the associated table. So it's the same sort of concept, but it's using permanent tables, not a temporary result set from running a query. How are you on that? Does that seem all right? And if you don't get it, it's fine. Here, let's do this. Let's write a join on these tables. Perfectly valid. It'd be kind of fun, actually. See if I can actually get my mouse to work. There we go. Okay, good. So let's write a join. So I'm going to do select all from, and I'm going to start over on orders. And I'm going to join that over to order products. On, and I'm going to do some aliases here as O is orders, as OP for order products. So O.ID should be equal to OP.order ID. That's what that's called right there. Okay, good. I'm going to do another join over to the products table. And I call it P. And then the ID over in P should be equal to, in the order products table, the product ID. Now it's mad at me for some reason. I don't know why. Use CSRDB, that should be correct. Select all from orders. An error. What's it mad at?
Is order, is it 0? Orders S. line 4.
Orders. Yeah, it's called orders. There's the name of the table right there.
Did you write it as a 0?
Oh, a 0. Thank you. Still didn't want to go away. From orders is O. O.IE equals inner join order products. Is that name correct? Yeah, that's right. Oh, I deleted my semicolon. Okay, good. There we go. All right. I'm going to order this. ID. All right, so let's look at some of these results here. Now, let's look at order number 4. Because order number 4 is the one we were kind of discussing before that had 2 products on it. Well, now with this actual join, we get a lot of information. We understand that the person ordering it was customer number 53. We've got a status of 5. We know when we placed the order. We know it cost $207. We've got some notes on it. If we keep moving over, we know this is the content right here, here, and here. Those are the contents of the lookup table, the order products table, these 4 columns. I shouldn't have clicked on that, it reordered it. Let me run this again. All right, here we are. We also have from the products table, the product ID 37 and also the product ID 92. We have their SKU, their price, what they're called, how many of them we have on hand. We have a description. We have everything. Now, this is a join. Again, it is a SQL query. Here is our SQL query, executed against 3 already existing tables, and it returns a result grid or result set that's tabular in nature, but it isn't an actual real table that's stored permanently anywhere. It's just a bunch of data being held in memory now. Does that clarify that a bit for you, Sudesh?
Yes.
Okay. So there are different terms for this kind of table. One of the best ways to think of it is as a lookup table or a mapping table, because it kind of maps. Let's run it again. We'll just select all from order products. It maps orders to products. It doesn't store anything beyond just what's the order and what's the product. It doesn't store the customer. It doesn't store description of the product because we don't need to. Knowing that product 37 is connected to order number 4 and product 92 is connected to order number 4, we can now, in a join, if we need to, we can look up that information if we need it. So it isn't that this table you're looking at right now is a join table. It's the wrong terminology, but it's used. It's only of use if you're going to do a query that includes a join. You see the distinction between those 2 things, Sudesh?
Yes. Yeah.
Good. Excellent. That was a good question. I like that. Any other questions?
So so this is a join function, or it's done auto. The table is auto-generated. You don't.
Well,
need...
how you generate it? No, we made this table.
Right.
Yeah, it had to be created. Just like you've created tables several times over the last few weeks,
Yeah,
This table had to be created like any other table. Someone had to create the customers table, the order
Yeah.
table, the order products. Yeah, it's not auto-generated at all.
but the data will be auto-generated after.
Well, the data will be generated because of a computer program that we write, that we make it put the data in here. We have to tell it to put data in here.
Okay.
So it's not, even that isn't auto-generated. We have to
Right.
write the code. We have to write code that will do that.
Okay.
You see
So,
how that
so
goes?
it's the purpose of this kind of table is to reference to
Yeah.
another function.
Yeah, exactly. If you step into this table, it'll connect you to two other associated tables. Now, why do we do this? Well, if we look at an order, let me ask you this. If we were going to try to take the orders table and store information in that table of all of the products in an order, how would we do that? I want everybody to think about that and answer it. Let's say we have this orders table. Here's the existing columns. If I wanted to kind of modify this a little bit and add to the table, so it did store product information in here, what would I have to do? Any thoughts, any ideas how we could do that? What could we do to the orders table so it would contain information on the products in a given order?
Would you
You
have
need
to
to add-
add? Oh, go ahead, Suresh.
Sorry, you go ahead.
I was just gonna see, would you add like a foreign key to the to the orders table that goes to the products table?
Yes, but let's look at that. Let's look at products. And let's say we have product number 2. And so we'll add a column in here. Foreign key. Is that what you're describing, Alexandra?
Yeah.
Good. Now, the problem here is that you can only have one product on an order. Because think about this. In the orders table, one row equals one order. Make sense?
Yeah.
So if I've got a column in here that points to the products table, it's only pointing to one product.
Right. Yeah, that makes
So-
sense. So you would
okay.
be able to point to multiple products doing
Right.
that.
Now, here's a way you could do it. We could add an orders table. We could add a column to the orders table that holds an array of product IDs. It could be, for example, 37, 92, 65. Those are the 3 products in that order. You could do that. And then once you've got that array, now you can look up each of those 3 products from the products table. Any questions about that concept?
No.
It's a really ugly way to do it, though. First of all, it means that you have to ask for information from the database 4 times. Once to get the order itself that includes this array, and then 3 more times, or at least once, to get order information, product information. So it's at least 2 inquiries to the database. And that's wasteful, it takes time. So this is why we put something together like this, move up here, order products table to combine the two. That way, with one query, and the query would look something like this, because Sudesh was totally right to think of join, the query would look like this. It would be a join. Like we can actually do where order.id equals 4. We run this, and now we're going to see those 4 things. Here's the order. Here's the customer. If we move over, we'll see that what we ordered is the incredible plastic hat and a small granite computer. With this, that's one query sent to the database, and we send that back to our computer program, and we've got everything we need to display information on the screen. We got everything. So that's why you would create a table like this. Now, remember what I said over the last couple of sessions, that when you put a table in a database in general, you want it to represent one kind of data and to hold information about one kind of data. And for the most part, let's collapse all these tables here. For the most part, that's true in this database. This holds address data. This holds customer data. This holds order data. This holds product data. This one is different. It doesn't hold data about a thing. It's a connector between two things. So there are exceptions to that, but I hope you can see why we created it. Okay, now finally, there's this other table here, and I want to explain these two parts of this name. Sequelize is the name of a JavaScript library that you can add to your JavaScript project that'll help you work with databases from your JavaScript program. Meta means metadata. So this table stores metadata that Sequelize library uses when it interacts with your database. Now we're going to see this in action to make it a little easier to think with. All right. How are we doing? Anybody got any questions? Okay. So let's look at a computer program that actually uses this information. In a little bit here, so give me a second to find it. Not what I wanted to do. I wanted to go open recent. All right, fine. I got a fair number of repositories here. All right, where are you? All right, I think this is it. All right, this computer program uses a bunch of third-party libraries. Let me get the stuff out of the way. Hold on a second. Okay. This uses a bunch of third-party libraries, and there's node module thing. I'm going to update any of them that need to be updated by running npm install because I haven't used this program in months. All right. Well, there we go. I wasn't in the library. All right, npm install. All right, it's updating some stuff, that's for sure. Look at that. Okay, so I've updated the program. Let's see if we can get it to start. All right. Through an error. So we were listening. There's some sort of database error. I'm not surprised. I haven't used this in a long time. Code not found. Oh, it looks like it's trying to connect to a database out on Azure. Okay, so let's look up here in the database folder. Maybe it's an app. Config. Yeah, database config. Okay. There we go. All right. Yeah, this is not the right project. Give me a minute to find it. I know I have it. I've built a number of programs that actually use this database structure. Nope. One of the challenges is having so many repos. I need to clean this up. All right, let me look somewhere else. Hmm. Where did this go? I apologize for making you wait. We'll get this. Hey, hey. All right. I think I have it. Okay. I think I found something. Okay. Thank you for your patience. Share my screen and show what we're talking about. All right, so here's a computer program that can in fact connect to a running database server, connect to a specific database, and interact with it. And if we look here, we'll see how we connect. Look at this data here. We have where the server is located. It's on my machine on the local host. What's the name of the database that I'd like to connect to? It's CSRDB. And if we go back here, you'll see that's what we want to connect to. We have what's the username and password. And we have the fact that it's a MySQL server, because there's other different relational database server programs. Now, never mind yet exactly how this information is used. I just want to show you that contained in this computer program happens to be all the information the program would need if it wanted to try to connect to the right database. So that said, let's get this bad boy running. Let's do an npm install, see if there's any additional libraries that need to be updated. All right, and let's see if we can get started. npm start. All right, the server is running at port 8080. I have a way to send communication to this program that's running that that'll tell it to connect to the database. I can do that using this little file here called test.http. So, for example, I should be able to get all of the addresses in the database. See if this will work. Yay, it worked. All right, so if we look here, let's examine this a little bit. I want to clarify exactly what occurred. Installed in Visual Studio is a tiny little utility program called REST Client. We look over here on extensions on the left, and I type in extensions REST Client. We'll see that I happen to have this installed already. And this is a client that'll let me send requests, web requests, and view the response. So what's happening here, and I'll run it again. If I click on this little hyperlink right here that says send request, I'm sending this text, which we're going to examine in detail later, into my running computer program. Now, I want to clarify, I'm not sending it to a database server. I'm sending this request to my running computer program. Let me click it again. When that request is received by my computer program, in turn, my computer program connects to the running database server that I happen to have on my local host server. And it sends a SQL command that says select star from address. We can do the same thing here. Let's go here and let's give ourselves a new, use CSRDB and select star from address. Run it. Oh, is it addresses? It's addresses. Run it. And look, there we have ID number 1 is at 366 Smith Rapids in Gardena, North Carolina. Let's go and look at our program. Look at that, address ID of 1, 366 Smith Rapids, Gardena, North Carolina. So What we're demonstrating here is most of a full stack computer program. We have a client, in this case, a thing called the REST client, that can send a request in to a computer program hosted on a server. That's my computer program that I started. Remember, I did npm start right here, and it started up my computer program. That computer program is sitting there waiting to receive requests. When I send in this request right here on line 7, by clicking right there, when I send that request into my running computer program, my computer program uses the information that I gave it to connect to the database server, request all the address records, and return them to my computer program. In turn, my computer program gives them to this thing called the REST client. You see the little symbol right here? That's that REST client symbol. The REST client opens up this tab and lists out what it received from my computer program. Any questions about this? All right. Now I'm going to show you a little bit more about how it was able to do that. And in fact, we're going to write a little bit of a command here that will make one of these, that will execute a query we designed, a SQL query against the database. So let's look over here. We have here, in terms of our structure, a source code folder, SRC. There's a bunch of other stuff you don't need to worry about. Some of this you're familiar with, package.json, some of it you haven't seen. But we have a source folder. This is where our application code lives, a bunch of JavaScript code. I've organized it into 3 different folders: a controller folder, a router, and a SQLized folder. Now, SQLized, again, is a JavaScript library that I've added to my computer program. I'll show you that. If we look inside node modules, they're alphabetical. If we go down here, you'll see there's a SQLized library. Now, there's a bunch of files contained in it. We don't care. I just want to show you that when I created this project, I added the SQLized library to my project. Now, I want to take advantage of that. Remember, library is just a collection of pre-made functions that you can take advantage of if you want. And I want to take advantage of some of those pre-made functions. So in my source folder here, I create another folder called SQLized. And I have in here a config folder that contains, as we saw before, information that can be used when I want to connect to the database. I want to show you where we connect to it. Let's look in this folder here called models. And that word, we're going to expand on that word a lot. But a model is a type of thing that your computer program uses or keeps track of. Products, customers, orders, addresses. These are things or entities that our computer program is meant to work with. Right now, we're just concerned with one model, one type of entity, and that is address. If we open this up, we'll see we have an address file. In here is all the information that I need for my computer program to work with these things called addresses. Now, there's a lot going on here. I do not expect you to understand much of this code. That's fine. But I'm going to point out from a very high level what's occurring. Because we've already covered a lot of this, if you recall, when we made our own computer program that would keep track of products. We learned how to use require to pull in JavaScript libraries. And you can see right here, we are using the SQLized library, and we're using a built-in function in it called model. We use that same syntax in our JavaScript programs earlier. We also use the exports. What are we going to export from this file to make it available for use in other areas of our application? Now, there's other stuff we haven't gotten into, but I'll tell you, you can see a little bit of logic here. Notice, for example, that we have an object called address, and we're running on it a function. Object.function. That's a syntax we saw all the time when we were back in the JavaScript world. What this does is it creates or initializes a type of entity, a type of thing that our computer program is going to work with called an address. And inside these two curly brackets here are the properties of that object. Remember that in JavaScript, objects are a combination of keys and key value pairs. Sorry, this is just a collection of key value pairs. So we have an object called an address. It has key value pairs, and what you see here are the keys and what type of data they represent. We have address line 1, it represents string data. We have address line 2 and city and state and zip. They all represent string data. Why do we care about this? Because this information is used by this really cool JavaScript library called Sequelize to work with the database. Notice that these 5 different properties correspond directly to the table columns inside our addresses table. So this brings up a really, really, really vital point. And it's one of the final things we're going to cover today before I turn you loose a little bit. So everybody just stop for a moment. We're going to cover something I've only casually alluded to, but is now super important. In front of you is databases. It's tables, and it's rows inside those tables, or entries. This is where we put data we want to be stored that's going to be used at some time in the future. It's persistent storage of data. And it's being stored in a tabular form, like I said. Tables are composed of rows and columns. Now, let's look at just this first row in this table. It represents an address in North Carolina. What we're looking at here is what's stored down in a table that's on a hard drive somewhere. Now let's go back here and consider what this entire folder right here represents. This is a computer program, or rather it's the code for a computer program. When we turn this computer program on, when we run it, all those instructions we've written are sitting there held in the memory of a computer. And the program's running and doing everything we told it to do. If this computer program needs to work with a thing called an address, this is a JavaScript program. So the thing called an address that it's going to work with is an object, which is a collection of key value pairs. And all that information about that object, say address number 1 in Gardena, North Carolina, right? All that information, our computer program is holding that information in memory. So it can work with it. It can read its information, it can change its information, but it's held in memory, in RAM, random access memory. So we have this really weird problem to try to solve. On the one hand, our computer programs work with objects being held in memory. But on the other hand, our databases work with tabular data entered in rows into a database table. They're not the same thing. This is just, if we look at what's highlighted in blue, it's just individual pieces of data in a row in a table. It doesn't represent a custom or an address object at all. Not as far as a computer program can work with it. We can look at it and know what it represents. But as far as the database is concerned, it's just one more row in a table. So we need a way to go back and forth between these two things. A way that when our computer program needs to work with an address, for example, the first thing it's going to want to do is find out, well, what's the current state of that address? Oh, I remember I kept track of it. I stored it over in the database. Okay, let me, the computer program, reach over into the database and grab the row from the right table that represents that address. I'll pull that information back and I'll create, boom, an object in memory that represents that address. And now your computer program has something to work with. And we do whatever we're going to do. Let's say we want to change the address a little bit because they changed the spelling of it or whatever. Well, we have another problem. That information that changed is only in memory, but we need to store it permanently. What happens if the computer program gets turned off in a minute and we lose that change? So now we need to go, okay, I've got this object in memory that represents the address. I need to use it to change the information down in the database. So we then take that object information, we create a SQL command that will reach into the database and change, say, the spelling of the word Gardena. Let's say it's garden. Maybe it wasn't Gardena, it was garden, okay? So we go back and forth between the objects in our program and the data in these tables. Any questions about that so far? Now, this is the problem that, or a technical challenge that every computer program that works with a database has to solve. So it's super common, and there's lots of tools available. But I want you to understand the basic problem we're trying to overcome. In this database server are databases. Here's a database called CSRDB, containing relational data tables. These are tables, and they have relationships one to each other. Customers have a relationship to addresses. We can look in here and go, oh, look, there's an address ID. That means we have a relationship. We've studied this for the last several weeks. These are relational tables. But our computer program works with live objects being held in memory. Any questions about that diatribe I just went on, the big long lecture? Okay, so this this library called Sequelize is an example of a type of tool called an object relational mapper, ORM. It's a bunch of pre-made functions that make it easier to do what I just talked about, to go back and forth between data in the actual database and objects in your computer program. I think we can even use it, depending on the state of this program. We might be able to, let's see. Yeah, we might be able to create an address. Let's see if this will work. Let's do 900 Point Place. I'm going to capitalize that bad boy. And that's in Point Boulevard, Wisconsin. I think if I write this, I'm not sure if the code works yet. It worked. Let's go over to our database. And let's run this again. And if we order by ID descending or ascending, no, descending. All right, so let's run this. There it is. We created this record. And again, I want to clarify what happened. I sent in this request right here. It was received by my computer program. My computer program took this information on lines 13 through 19 and created in memory an object representing this address. Then the portion of my program that uses SQLize took that object with these key value pairs. Address line 1 is a key, 900 point place is the value. Address line 2 is a key, apartment 4 is the value, and so on. It took that object, that collection of key value pairs, and created some SQL that did an entry. It's insert into addresses table, the values, 900 Point Place, apartment 4, Point Boulevard. We've built that. We've done that SQL over the last couple of weeks. We know how to write inserts, but this cool utility called SQLize created the SQL for us. And then it sent that command to the server, and lo and behold, the server obeyed because we did it right, and it created a new row in the table. So we went from an object in my computer program down to an entry in a relational database table. Object relational mapping. Now, I can go backwards. If I want to get that specific address, I can go address number 102, hit send, and look at that. I retrieved that information from the database. I know it didn't look like anything changed. Let's try to get address 100. Look, there's address 100. Let me change it to 102 so you can see that it does in fact work. There's address 102, the entry in the database table, the addresses table that we just created. So we've gone the other way. We went from a row in a relational database table. We pulled that information into our computer program. Our computer program created an object in memory. It's an address object with key value pairs, like you see right here. And it took that object and sent its information to my client called the REST client. So there's 3 parts involved. On the left, you have the REST client. In the middle, you have my computer program. And on the right, you have the database. And we've just gone back and forth between all 3. Any questions? All right. So let's see if we can actually do that with our project we made a while ago. Stop sharing. I'll try to find that. Now, Dana, did you get through creating most of that?
So I'm at the point where some videos were, I guess, not uploaded.
Right, they're missing, right?
Yeah.
Okay, I'll show you how it works. It's a pretty simple application. I think we called it complex.js. Is that right, folks?
I think so.
Yeah. Yes. Okay, good. All right, let me share my screen, show you what we're talking about here. So this is our simple console-based application, okay? Let me see if I can get these controls out of the way. And I think if I do an npm start, it might run. I think I left it in pretty good state. All right, yeah. So pick from the following operations: A, list all products; I, find product by ID. Okay, so let's do an A. Oh, it doesn't have anything. That means that my db.text, yeah, it's empty. db copy.text is our reference content for our database, so we would never lose it. We run that again. It's a real great program, super sophisticated. All right, so we're gonna do A, list all products, and it listed all of them. And we built everything in here. We'll create, read, update, and delete, okay? But beyond the fact that like this is a pretty silly thing to have a user interface that is the terminal, I want to point out that the same concepts are occurring here. We have 3 different elements that work. We have a program called the terminal, and when we run it, when we run our program, the program called the terminal is sitting there ready for us to input something. When we do, it sends it to our program. Our program then has to read contents of what we're calling our database, retrieve them, and then send them to the terminal so the terminal can display them. So we're going to modify that a little bit and make it so that our program actually reads information from a database. Because again, what we've got right now is really janky. Let's do an I, we'll do individual, and which ID? Product number 2. It's our Velvet so far. Okay, good. So that's where we were. Anybody need any other refreshers on this program? I know it's been a little bit since we used it. All right. So here's the problem. We have in here, a text file that we're calling our database. It's certainly not a database. Over the last couple months, you guys have studied databases in detail. This is a text file, not a database. But you can see a potential structure for a database table. I think we actually have everything. We have an ID, like primary key ID even. We have a price column, a SKU column, a name column, a quantity column, a description column, and an ID. We have all of our columns. So we could design a table. That'll be our first thing. Let's design a table, okay? With these in mind. So I want everybody to follow along. I'm going to give you this program in a minute, but for now, let's all just, this is more work, more practice on building databases. Collapse everything, close all your tabs. So you have a nice clean workspace. Okay. So we want a new database. This 4th icon from the left, it's shaped like a cylinder. That's a database symbol. Creating the schema, click on that. And let's call this complex DB, because the project is called complex. Click apply. Review the SQL script. It's going to run this SQL against the database. Create schema complex DB. All right, that seems fine. Click apply. Click finish. All right, and we should be good. If you go over here and do a refresh, oh no, it already appeared. There's our database. Now it doesn't have any tables. Let's see if we can create a table on here. Now you guys are going to need to do some research. I want your help on this. If I'm going to make a table here, what's the first thing I want to put down?
Use complex DB.
Absolutely. All right, now someone look up the syntax for creating a table and tell me what to write here. Unless you have it memorized, which, hey, great.
Create table.
What are we going to call the table?
Price.
The table itself. We'll have a column called price. Remember, a table has multiple columns. What kind of data is this table going to contain? Data about what kind of thing?
Products.
Good. We'll call it products, but we'll spell it correctly. All right, what's the next thing syntax-wise? Any of you can look this up,
You need parentheses.
like here.
And then, yeah.
Need a semicolon there, okay. All right,
And then you can add like the column and data type. So like price, and then I think integer with price.
okay.
Or do you start with like ID for that?
I'd like to start with the ID just because it's almost always the way this is done. I don't want to get you guys to have any bad habits. So yeah, we have an ID column. You can see it over here. And okay, and then we need a data type. What data type do we use for ID most of the time?
Integer.
Integer, okay. Now, we want this to be a primary key. So somebody want to look up how you make a primary key in MySQL that will auto increment?
Is primary key.
Nope. Look up the syntax. Unless I'm wrong, but that's not the way we did it in the lab the other day.
Are we putting not null and then auto increment?
Yep, so you can't have a null entry. You've got to have something there. And we're going to auto increment. Is it like that? Yep, okay, good. And then farther down, we did primary key, right? Is that the correct syntax?
Yeah, that's correct.
Okay. But in between, we have the rest of the columns. Okay, good. All right, so what are the other columns? Let's go back here. Price, SKU, name, quantity, description. Price, SKU, name, quantity. All right, I just want to get them out. All right, so price. What data type do you think we should put there?
Integer.
Integers are whole numbers, right? 1, 2, 3, 4, 5. Our prices will probably include pennies.
Would it be decimal?
Absolutely. Are we going to require that when we create a product that we have to put in a price? What do you guys think? There's no right or
Yes.
wrong answer. Okay, so if we are going to require that, then we have to say not null. We can't create a row and not have contents there, which is a perfectly fine decision. I like that a lot. All right, so a SKU, what format our SKU is going to be? And does anybody have any questions about what a SKU is again?
Maybe a string?
I think so. Let's go to Wikipedia and actually just look this up. This is a nice little educational thing here. Stock keeping unit, inventory management identifier. In inventory management, a stock keeping unit, abbreviated SKU, is a unit of measure in which the stocks of a material are managed. A distinct type of item for sale or purchased or tracked inventory. All right. can also refer to a unique identifier or code. It refers to that stock keeping unit. Okay. These identifiers are not regulated or standardized. So, see these examples here. Scannable barcode, scannable code. UPC numbers. It's a pretty complex thing. This isn't a decision you would make that would come from the business. So let's just make it a string. So what is the data type in MySQL for strings?
Varchar?
Yep. And how long, how much memory, how many spaces do we allocate for the SKU, do you think?
Maybe like
20.
10.
Okay, let's just say that the business has said that our SKUs are no longer than 10 characters. That's totally fine. Excellent. Now, I want to point something out. Does anybody else notice that line 7 and line 9, the names of my columns happen to be blue? You see that? Well, that's weird. Everything else that's blue is a SQL word. Use, create, table, int, not, null. All of these are parts of the SQL language. Decimal, varchar. What does that tell you about the word name and the word description? They're part of the SQL language. Now, that doesn't mean that you can't use them as the names of columns. But often, depending upon the type of SQL server that you're using, you might have to put that word, it's called a reserved word, inside of square brackets to clarify that you mean for it not to be interpreted as one of the key words of the language. All right, so name is also a string, right? We don't know how long these are going to be. We better go 255. Some products might have really long names. By the way, I think that that square bracket thing does not apply in MySQL, which is why it's blowing an error on it. It's mad at me. So let's take that away. Most of my SQL programming, I've done a disgusting amount of it, has been with the product from Microsoft called SQL Server. And in that variation, it does require the square bracket. All right, so quantity. What do you think here for a data type?
Integer.
Absolutely. What about description?
String. Gotcha.
Absolutely. Let's go to maximum size. All right. I think that's going to make the table we want. We're going to have a primary key. It's an integer. It'll auto increment. We've specified that it's the primary key. And then we have price, SKU, name, quantity, description. Those all seem to be right. All right, let's run this bad boy. I got a green. Anybody not get a green? A success?
I did not.
What does it say in the message? Or do you have, go ahead.
You have an error in your SQL syntax. Check
Okay.
the manual.
Yeah, look closely. Do you have any red squiggles, even if they're really small? Are you
Yeah,
maybe
I think
missing?
I'm missing the ID on the primary key. Yeah.
Oh, that right there?
Yeah.
Good, excellent. Fix that, see if it'll work.
Yeah.
Good job. All right, so if we do a refresh, now we have tables.
Yeah.
Okay, good. So we made our relational database table, and we want to connect to it from our computer program. Instead of storing information in a stupid text file, we want to store our information down inside the database table. Make sense? Okay, good. So we're about time. Here's your homework. I want you to put all of this information inside that table. So the first thing I need to do is make sure that this computer program is shared with you. Oh, no, never mind. You guys built this yourself. I will send this db.txt file or the contents of it. I'm going to put this in Discord. Okay. So let me go to Discord, student forum. And this is complex.js. All right. Okay, so I just sent that text file in Discord. So your homework is really simple. I want you to, like I said, just create the entries in your table that contain those things. If you want to start studying the library called SQLize on your own, go for it, because we're going to use it. You might look up how to add SQLize to a JavaScript project and see what you can find out. Okay. Okay. Any questions about tonight's stuff? Okay, cool. Excellent. Great job, Sudesh. Whatever you can over the next 2 days, please continue working on that homework.
Yeah.
Okay, cool. Awesome. Okay, I will see you all on Wednesday night.
Thank you.
Thank
Have a
you.
good night.
Thanks all. Bye.